So the range is the minimum value and the maximum value. So the range will be -50 and positive 260. That's on page 2-14. One is called the range, one is called the span. You're welcome. Yeah, those definitions sometimes is it's slightly, especially when they're talking about range. I think when you're talking about daily, the range and the span almost the same thing. But in here, they define the range as a minimum and the maximum value. The span is the difference between. Yeah, any question you can just come up. The best way is if you have a question, you bring up, then we can discuss it. And I think even like module 6 is a big section, lots of pages down there, but we're not gonna go into very detail about module 6. So I would where is the head pressure? The head pressure is the hydrostatic pressure. So it's depends on the density and it depends on the height of the liquid. Okay. Any question you guys have for now, or you guys just want me to finish the thing we stopped yesterday? Okay. So it's AO2. The fuel guy. Yesterday we finished before this one. Right? We said that these pages are very important. You guys all have this picture memorized, I believe. it doesn't matter if the tank is full or not. You just try to measure. It's the formula. Your pressure is equal to that numbers. You can either call it P or you can call it phi or pi in Greek letter. Then that's the liquid density times the gravity acceleration times the heights. But depends when you measure that, because we're talking about a pressure measure. If it's an open tank and open to the air, then you measure from the bottom, that will give you the hydrostatic pressure. But if close the tank, there might be something on top with changing the pressure compared to the air pressure. So you need to use two pressure sensor, one on top, one on bottom, and you have to subtract the bottom measurement, subtract the top measurement from the bottom measurement. That will give you the head pressure or hydrostatic pressure. Okay, so there's also other temperature measurement device. Because certain time we are not able to actually touching the body or touching a object to actually measure its temperature. So that's where we talk about non-contact temperature measurement. The non-contact temperature measurement is they give you a bunch of reasons why you cannot be touching it. Like those are the reasons. It's for all the reasons it could be. But it said all the object when they above absolute zero temperature. The absolute zero temperature is we call the negative 273 point some degree Celsius, or they usually they have a temperature scale as a Kelvin. That's where the absolutely zero temperature is. So any object, usually you cannot stay that low temperature. They will always radiate thermal energy. So that's the heat in the form of sometimes they call it infrared radiation, but the proper term is electromagnetic wave radiation. The amount received, that will be depends on a few things, the surface of the object or the type of the object. So some are radiation and the emitter energy. So this E is emitted energy. Reflect energy, if the surface is really, let's say, shiny white, they can reflect energy, heat a lot. Or if a transparent like a glass or certain material, the light can shine through, there might be the energy from somewhere else can travel through. But if it's a black body like metal or anything, they cannot let any those lights or anything shining through travel through. Then you cannot measure the transmitted energy. So what you can measure that is they call the infrared detector, or the book used the proper term. They call the infrared pyrometers. So on your book, on page 5-15, it's called the infrared pyrometer. Pyrometer is a pretty general common term, and you probably will say this term on your exam. So the use for that is you can make non-contact temperature measurement. So that's important to know for the infrared pyrometer. And if I ask you a question, I said, okay, I want to measure object temperature remotely, far away. What type of equipment I have to use? And you need to give me the right answer. Yes, no? Yeah, if you cannot give me the right answer, I'm going to show you something down here. Ruler, yeah. Whenever people say ruler, I think you are in my class before. Okay, so temperature emissivity of a non-black body. We're gonna show you a little bit of things here. Review the ratio parameter. So radiation parametric temperature measure device operate on assumption total energy emitted by a body, the result of its temperature. So basically, if an object have a higher temperature, it will emit more those we call the radiation and heat energy. If the temperature is lower, it will emit less radiation energy. So that also energy can be reflected or transmitted. Because the reflected is basically depends on the surface. If it's a shiny surface, it's a white surface, or it's a black surface, it's a like a rough surface, it will not reflect too much. The black body will almost like taking all the radiation energy by other object. The target object radiates. That's the radiation energy. That's the reflect energy and the transmit energy. They can all go into the detector. So to actually accurately measure the temperature of this target, we don't want this transmitted energy. We don't want this reflected energy. We just want to measure the emitted energy or the radiation energy. Because that will tell us the true temperature of this target. Because a black body, they cannot let the transmitted energy, nothing can go through because the lights didn't go through the black body, and the black body will absorb all the reflect energy. It will not reflect back. That's why a black body will only, if you measure them, you are measuring emitted energy. But a non-black body, they will usually can either have a transmitted energy or reflect the energy down there. No, I'm not talking because it's just a bunch of statement. There, no point. You guys all can read those statements. And no point for me to. If something need explanation, I might say something, but oh, because I'm so quiet, you guys think I'm too talkative? uh, some of the statements, sometimes I say too much. Yeah, you guys never have a interactive class with me. Yeah, that is, at least in the class, I can see you guys' face, see your movement. Some people will show me a confused face. Some people will show me a happy face. So I know if you understand the subject or not. But mostly Asian students just gonna show me the poker face. Can't get. Radiation came from D or above. Which type of radiation is the result of object's temperature? A. Good. You guys are super smart. Of a black body is C. Right. To compensate for effect of temperature can be determined using emissive calculation. That would be C. Good. Whoa. Is A. Great. So Yeah, I think Alan, Alan is the person. He he gave me those software, and he's the guy making the exam, and he's the guy made those quiz questions. So that's why some of the things in the quiz. I know most of you guys are good, but there's certain people they will just don't show me any face expression, so I don't know if they understand or not. Okay, so I mentioned to you that thing you have to know if we want to measure uh, temperature from somewhere remotely or not. We call the non-contact measurement. We use infrared pyrometer. Uh, Another thing, I think I have a short video I can show you. Make sure the sound is not too loud. Oops, I'm not sure if I choose the right one. It's also nowadays very usual for the maintenance person. They will have those thermal imaging camera. Like even for electrician, we want to check the panel, the equipment, because usually the big cable connection, that's where after certain years of wear and tears, uh, I think in year one, you guys learned about a copper conductor, aluminum conductor. Yeah, over time, and the metal, we kind of try to lose in the connection by itself. Uh, so if you don't do regular maintenance, try to tighten those connection or doing cleanup or everything, it could causing high resistance contact, and when you draw large current, that will become a hot spot, which will be causing fire, causing anything. I heard a few years ago, it's a winter time, one of the apartment or townhouse complex in Delta, uh, they never do those maintenance for maybe 10, 15 years. And that was a cold winter, so everyone crank on the heat. And one day, one of our instructor, he's working for a high voltage company. He got a call. They said that they lost power. They go there. They look. It's not the high voltage. It's those low voltage cable. It's aluminum cable. It's all melted on the floor because over the time it just the contact resistance increase, and when everyone crank on the heat, they draw lots of current that becomes so hot inside there, it just melted all those cable. So we nowadays lots of requirement is you're gonna use those thermal imaging camera to do checkup, to do looking through the panel, looking through the equipment to find where is abnormally hot spot or where you have a abnormal high temperature. That makes sense? So a thermal imaging camera, where you use them, that might be an important thing to know. Practical temperature measurement, the speed of response principle, because heat energy need a transfer from you. Like you can use a remote those non-contact measurement, but you are measuring the emitted radiation thermal energy. Other than that, when you measure them, the heat energy have to transferred from the object to the sensoring device, and those transfer is not happen instantaneously, so it take time for that the energy transfer to happens, and the transfer the time it's they mostly refer to as the RC or constant time in this in the book you guys bought, but it's it's not just RC constant time like you guys learned that LR inductance, the current increase in the inductance also follow that time constant. And the time constant, I believe what you guys learned is how much time constant take for either the voltage or current to reaching the almost the steady state in a DC circuit. Anyone? I was sleeping in my class.
I remember it somewhat.
Okay, so how many time constant for the five time constant? Good. Yeah. So 5 time constant, that's a universal thing. So it's not only happen in your RC circuit or RL circuit, even for the response of those energy transfer or something, it's all take 5 time constant. So you better know that. How about another thing? I could show you. Take a look. What's that? So the dynamic response of a closed loop system, Here is a closed loop system. I guess you guys are all perfectly familiar with this picture now. And we usually have a full block down here. So the controller variable could be any of those. The set point is desired condition of controlled variables. You can set them as a programmer or use lots of different devices to get them in there. So the process might not be always at a set point. You could, one thing is the operator can change the set point. Other things, some unwanted disturbance, we cause the control variable to change from the set point. When they change, the closed loop system supposed to make a correct action to cause the control variable to matching the set point. But it takes time to make that corrections. So the measure of the loops correction action time is the function called the dynamic response. There's a few things going to affect this response time. So they're using a change of, they want to change the set time. So you might want the temperature to increase by 8 degrees. That's the operator make the changes down here. So now all the instruments have a time lags. This is the time from the moment change received and until it produce a proper output signal to do the correction. And also the temperature sensor taking time to respond that temperature changes. So even for the adjustment down here, yeah, you change the setting down here, but it take a little bit of time for they to send the signal down there. Now we have the thermal sensor. The sensor have to sensor in the temperature. Then the controller have to process that information. And controller have to send the signal to the valves. It takes time for the valves to open. So let's try to see this again. Now we can see. So there's something called the dead time. It's between the moment the final control element is changed to when the correction action begins. So it takes so long for the setting, the sensoring device, the controller sending the signal to matching, try to do the correction action, but nothing happened yet. Now there's more steam getting to the heating coil. So you also take take times for the water in there to be heated to the high temperature by the heating coil. So you need to have the energy exchange between the steam heating coil and the water. Then take time to heat the water, right? The more water in the tank, the longer it takes. So now the water temperature start to change. It usually take a 5-time constant for the water or the new temperature is reached. The total time from when a step change made until the controller variable complete change to new state is called anyone? Time lag. Oops. That time. Oops. Time take for instrument to change its output after receiving new input signal is B. Good. Delay that occur due to the static inertia of the control variable tank is called anyone? A or D? It's A. Cartland, you are smart. You gave me a multiple choice, right? Time take for the increase in steam to travel from the valve to the coil is called so for this one, it's not ask you because we are now in the controlling industry. We're not going to ask you to figure out they how do they to identify what's the dead time, what's the lagging, what's the pure lagging, those things. But if you know it take 5-time constant to reach a steady state, I think that's good enough for us as electricians. So the delay losing, we don't care about too much. Don't need to worry about this one. Okay. I believe that's all for section for module 5. One more thing I probably want to say is whenever you try to testing any of the either instrument or any of the transducer or sensors, if you try to make sure to check on them, to testing them, you always disconnect the instrument or device from the circuit, because you don't want the connected circuit to affect your measurement result, right? Just like if you have a resistor in a circuit, if you try to use the ohmmeter to measure the resistance for that resistor, you're probably not going to get a very accurate measure, because there might be have some other resistor in parallel with it. So that's why if you want to actually make sure that resistor to test it, to measure it, you have to disconnect from the surrounding circuit. So that's another basic thing I think you guys should know as an electrician. So if they ask you why you have to disconnect a transducer or sensor from the circuit, it's try to isolate them so they're not gonna be affect your measurement. Okay, so that's module 5. And any question? Should we go to module 6 now?
Let's do it.
Okay. Module 6, like in your book, it's a really big one, but as us as electricians, especially construction electricians, we're not gonna be focused too much on them. We only need to know some basic things. So module 6 is talking about feedback controller. And control strategy and those applied controllers. This one we already know. If you have a cruise control system through the car, and you set the speed, and if the car either goes up a hill or go down a hill, when the speed changes, they will always make the adjustment based on whatever the new speed is with the setting speed. So we call this one the arrow-based control system. And we also call it negative feedback system. So here is some kind of block diagram try to show you that. So this is considered as an arrow-based negative feedback control system. Another one, they try to explain the things in this module 6 is they call a liquid level control system in a process. So they have a pump, they're gonna drain out this liquid for produce or production. And you have a liquid level transmitter, and you have a controller, you have a controlling valves, try to controlling the input of the liquid to the tank. So this is a totally a closed loop the control system, and they use negative feedback because if you can set the liquid level down here, if this process, this pump drawing more from the tank, the, the level will drop and the level transmitter will send the signal to the controller. The controller supposed to open the valve, let more liquid into the tank. But there is a different ways which we can controlling them. So this is a very simple one. We're not talking about this one. We're gonna talking about automatic control one. There's a few idea down here. Is a one for the controller. They have two things. One is the summer point. The summer point is a comparator. So your set point value with the measure, the sensor, the measure, the feedback value. So they will, in this summer point or comparator, give out an error signal. And the controller will, based on that error signal, do a calculation to send out output signal. So the error is the set point subtract the process value is which is the measured feedback signal. Then produce an output to do respond to the error detected, and they might have a providing you, so you can make an adjustment to, you might want to set a new value for the setting point. This feedback is very important. Without this feedback, this not going to be become a closed loop system. And also because if the action you're taking is how should I say it? If the level is low, so you want to control them to open the valve to bring the tank level high, and if the level is too high, you want to use that to control for the input of the liquid to drop the level lower. So that's considered negative feedback. The set point is the desired value of process variables, and I guess you probably somewhere in the exam they will ask you what's the set point is, and I already mentioned to you before. So set point is the desired value. In this book, they're going to talk about 4 basic modules of control. So one is the on-off control. On-off control is your output signal. So you have a valve down there. The output will turn on this valve fully or turn off this valve fully. There's no adjustment in between, just fully on or fully off. That's the on-off control. It's more like if you have a baseball heater in your house and you set the temperature. If the temperature is below the required, it will turn on that baseball heater. It doesn't matter your baseball heater is a 1 kilowatt, 2 kilowatt, or even 5 kilowatts. When they turn on, it's all on. Proportional control is the on-off control is not considered continuous control. It just turn on, reach the temperature, turn off. Below the setting point, they usually have a dead band or limit in there. I think in the motor control, we call that a cut-in and a cut-out. So if you reach the cut-in, it will turn on. If you reach the cut-out, it will turn off, those type of things. Proportional control, the next 3, they consider as a continuous control. So the proportional one is the output signal is proportional to the size of the error detected. So the proportional control, they always require or need that error signal to make the adjustment. If you don't have the error, there are not going to be any changes. When you detect an error, then they're going to do the controller gonna send in an output signal. It's proportional to the size of the arrow. Integral is integral and the derivative. That's another two things. I think most of you guys, you never learned calculus in high school, right? So that's to put it in basic way is that's a mathematical function. They can somehow the integral is it take time to you have an arrow signal. You will based on how long that arrow signal down there, you will try to eliminate that arrow in the process. Yeah, so then derivative is because the integral gonna sometime take a based on the gain you're setting in there, it take a pretty long time to correct that error. And derivative is if you put in them all together, the derivative is try to make that correction time shorter or faster to respond. But when you're putting them all together, there is a chance you're going to make the whole process unstable. So I think I saw Ethan. He took those calculus course. He think those things bring back the bad memory. So in here, oh, sorry, Ethan, you're gonna get a version F exam. That's why you need those bad memories. For everyone else, you don't need to worry about that. So that's some kind of thing. It's a calculus function, mathematical function, but they try to integrate into the control system. The good thing, even for people in this industry, now, especially with the advancement of technology, the equipment you bought, let's say, when we're doing the lab in the BCIT there, those VFD controller, you can actually, you set those, you said, okay, well, I want a proportional control. I want a proportional with integral control. I want a proportion with integral and the derivative control all together. The equipment, we does that for you. You don't need to set in anything yourself. So, but for the purpose of this course, if you get a version F exam, you need to know those. If you just get a basic exam, we're not going to test you on those. All you need is some basic, maybe you know 4 names, and if you know what's the advantage and the disadvantage in there, that's good enough. So for the on-off control, basically, if the sensor tell you the level is too low, they will turn this on. In here, more like a 2 floater switch, 2 sensor down here. If the level drop below this sensor, they will turn this on, try to fill the tank up. If the level go above the top one, they will close the valve to stop the incoming supply. So on-off control basically is like that. And when this one, either this one's a continuous drawing or the demand changes on this pump the pump might draw more or draw less, doesn't care. You only based on these two sensors. You go below this sensor, they will turn the valves on. Above that sensor, they're going to turn it off. So the liquid level in the tank is more like this. When you go below, you turn on, you try to fill them up. Go above there, you stop. So you keep drawing, the liquid level go lower. So the tank liquid level is constantly changing. You never reach a steady state. In between here, they call the dead band. Don't worry about that. And the bad thing about this is because the control valves, those final control element, it's constantly being turned on and turned off. It might cause very fast wear and tear on those final control elements. Another one they talk about, if you have a smaller tank and compare you have a big tank. The big tank you can see, because even you drawing them, it take a longer time for the liquid level to go lower, and also it take a longer time to fill them up. So it's not being turned on so frequently like a smaller tank. That's just a comparison down here for the advantage and the disadvantage for those on-off. So the on-off control method, it's simple, it's reliable, it's economical. So that's the advantage of them. So you don't need to spend too complicated control system in there. It's very simple, it's very reliable. And the disadvantage is you'll never reach a steady state. It's continuously cycling, and you always frequently start and stopping the equipment. You might cause long-term damage for there. So what color is those letters? Red. So you know why they are red, right? Green. Yeah, if you get them, they are green. The application usually, if you have a large capacitance, the capacitance you can read your book they're talking about is depends on the value, and so if you they talking about if you try to heat a house with on-off control, that's fine, because when you turn the heater on, it take a pretty long time to heat the whole thing up. When they reach the set of the temperature, you're gonna stop the heater, but the house have those insulations, thermal insulations, so it also take a while before the temperature gonna cool down. Then you have to turn on again. So that's considered a large capacitance process. So it's okay for them because the benefit is overcome the disadvantages. That's the on-off control. Then you have 3 different type of continuous control method. Because your on-off control is always keep changing, and the proportional control and all those continuous control, they can reach a steady state in the process. So we will say in detail, but by using those control methods, your tank's liquid level will reach a certain level and will stay there if you don't make any more changes. This is a proportional control. So for this proportional control, if you set, let's say you set the tank level at there, and the demand, the pump is drawing at a certain level, the liquid level in the tank will reach a certain location down there. is not going to change it because you will constantly monitor what you draw and what's your supply down there. You will try to make the supply here, the valve will open to the value to where this pump is drawing out from the bank. Last two slides. This one or this one? Oh, yeah. You're sleeping in my class. When I told you that you were sleeping when other people told you that would be on the test, then you wake it up. Joking. I know you. You're not going to sleep. Okay, so this valve is not like the one in on-off control there. It can be only open or close. This valve can be gradually open to a certain degree. So first, they give the example is if your pump drawing more liquid from the tank, and the level in the tank are going to change. The level in the tank change cause an error signal. The error signal going to send to the controller. The controller going to adjust the valve opening to matching the degree, matching the drawing from the pump. With proportional control, there always be some permanent error. So this error is the liquid level in the tank. So when you're using proportional control, when the demand changes, you're not gonna be come back at the original liquid level anymore. They require the liquid level either go lower or higher to do this proportional control. So that's why a permanent error offset necessary to keep inflow amount of process supply. The value of permanent error depends on the outflow demand. So this is one, I think, called the characteristics of the proportional control. That would be an important thing to know. Tristan, did you see this one? Yeah, okay, good. So you better remember this, or you better take a note or write down something about this. The proportional control, there always be some permanent error down there. Don't need to worry about this. This is they try to use mathematical equation to explain what's going on down here. This is considered the size of the offset. That's the arrow. It's not automatically feedback control. It's this proportional control. Good. Yeah. So because they are based on the level down here, then they taking that level, the measurement signal go there to compare to make the error signal. Then they base on this error signal to open the valves for the incoming water or incoming liquid. So if there's no error, they're not going to make any adjustment. The valve, how big or slow the valve changes, it depends on this error signal. So that's why for proportional control, you always need that permanent arrow required. This is a mathematical function you don't need to worry about. They try to come up the total gain for this process. They calculate as 2.5 liter per minute per milliamp. That's the control signal you're going to send out. If you try to change it to increase the flow or decrease the flow, that's where the controller send out to the final control element. They're going to send out a milliamp signal to do the adjustment down there. But those calculations you don't need to worry too much about. It's try to use mathematical function. Oh, now for Ethan, he have to know. Because I believe he get a version F exam. The proportional control, like this one is really good if we, in the BCIT, we have the lab to show this. We also have a tank filled with water, and we have a pump controlled by a VFD. The VFD gonna keep the water. We have a circulating pump, right? We have a one top tank, one bottom tank, and the pump gonna pump the water from bottom tank to the top. And so if you only use a proportional control to control the water in the top tank to control the VFD, right? The VFD will increase the speed or decrease the speed of that motor, which driving the pump to pump the water from bottom tank to top. If you use a proportional control only, you could see the water level if we change. If you open the valve to drain more water down there, the VFD will speed up to pump more water from the bottom up, but the water level on the top tank will go lower. Or if you close it, and the water level will go higher. So the change of the water level depends on the gain, depends on all those settings down there. But the water level change is required for this proportional control. So the water level change, that's the error. That's the permanent error required in the system. So if you open the valve more, you drain more water. So that's where you change the demand. When you change the demand, the VFD will try to pump more water to meet the demand, but your water level will change. So the change of the water level, because originally you set the water level at which heights, the change of the water level, that's the permanent error in there. But it's hard to just to say here to understand from this point. So as long as you know what's important to know, that's good enough. Also, we're talking about the gain or for the system. If you set the gain is too high, because the higher the proportional gain, the lower the offset error. So but if you set the gain is too high, your system will become unstable. So your system will always be overfilling or drilling. If you set the gains too low, you will have a bigger offset down there. So They talking about those things. You have to the experienced person will try to, or the guy doing those things, the engineer designing, installing, all those things. They gonna be try to find the optimal uh, operational point for that. Uh, if you, as a basic understanding is for the controlling system, the system gain you cannot set too high. Uh, on this page, there is one thing. It's marked in red down here. It's called a dynamic characteristics of a control system. The dynamic characteristics is considered as unsteady state of the operation condition of the process changing. So I don't think this is on your PDF file anywhere. You can take a screenshot or maybe just write down the statement down here. One thing I hope you guys understand is because you're not gonna have the same exam everyone, right? So the question is pulled out from a question bank. Inside the question bank, let's say I said for module 6, you will only have about 2 questions from module 6, but the question in the question bank will be more than 2. So when they pull out on your exam, you might say this question, you might not say this question, but to cover for everyone, I usually we tell you more. You might say on your exam, but you never know. I never know which exam, which question you're gonna get. Okay, so for this part, you guys have to know this. Hayden, did you remember this? Not falling asleep in my class?
No, I got it.
Okay. Yeah, John, you also have to remember this. I don't know if you're gonna get this question or not, but if you get, you know how to answer them. Okay, the integral control. So if on top of the proportional control, we can add an integral control on there. Integral control is working over the time. They detect that they will detect if there's an error in there. They will try to increase, let's say, because your demand changed, so your water level dropped. The integral in there is they're gonna, based on that error, they will say, oh, okay, even my input is matching the output, but I want to bring the error back. So they will increase the opening of the valve. They will try to increase the incoming. So it will take a little bit of time. When you're proportional, you will drop the water level to meet the demand, but the integral will try to bring the water level up. Oops. Then the next one, The integral also, it take a pretty long time to reach that steady state. So sometime you can see they will overshoot a little bit. The water level might go higher than it required. Then you will make another adjustment to drop it down. So the integral control, it take a pretty long time. That's where they add this one called the derivative control. The derivative control is they could increase the speed of the control loop recovery. It's also another mathematical function. They will monitor these changes down there more frequently. They will make the adjustment to shorten the response time. So if this is a proportional and the integral control together, the recovery time gonna be this long. If you add the derivative function in there, they could be bring into the steady state much quicker, much faster. So that's uh, that's all I think you need to know about this module 6. Module 6 in your book is a big section, but it's not for us as electricians. For electricians, we only need to know what type of, what's the field different type and what's the advantage and disadvantage of each one. Yeah, we go for coffee. We back 9:30. Okay, see you guys in a little bit around 9:30. Okay, you guys back here?
Yep.
You ask me why. They want you guys start a new session, then have the exam afternoon. I have really no idea. It's just give me a second. Let me reply a quick email. Uh, they I'm only respond for teaching the course. I have no idea about the schedule. So someone else made the schedule. Huh. Year 4 is tough. You know that. There's a lot to learn in 4 days. I think you never had a, if you had a Bill Schoolmore to teach you, you will not say that. Okay, don't say that I said it. Okay, Bill is a long-term instructor here at the BCIT, and what I heard is last term I worked with him. He's on vacation right now. A student told me, he said he only, the thing he talked only shows up about 50% on the exam, and a lot of things he talked about you never get tests on or whatever, but he wants you to know everything. That's why my idea is we want to give you some introduction. We want to show you certain thing, and I want you to pass the exam. Yeah, test is one question at a time. I don't think so, because I'm not the guy makes those type of decisions, and I don't think it depends, right? That's why I said you come to my class, you follow around, even you sometime fall in sleep, or you was chatting on your phone, and you watching some other things. But if you just when I say it's important to know, you know those, you should be pass my exam, no problem. For code question for IP, I know certain things for sure. I know lots of code, but depends, right? Because Jeff is teaching the code, and during certain time you can ask me. I if I have time, I will try to answer you. But if mostly if you have a code question, you should go to Jeff because he's the instructor teaching the code. And Jeff's pretty good with the code. He's an inspector before, so he know a lot of about the code. Let's see. No, I think Paul probably doing year 3. You had Paul before? Yeah, he's a good guy. So we're gonna finish the last one. It's module 7. Module 7 also, we're not gonna have too much things talking about. Okay, module 7 is the final control element. You have a control output signal, then go to the final control element. You make the adjustment to manipulate the control variables. For so far, like now we have a more new technology in there, but mostly before, the final control element is a control valves. So the control valves is a device you can make adjustment to control the variable. Let's say usually you can control the ingredient, like you can control liquid, gas, vapor, steam, lots of things in there. And so that's one big block of the control loop. And if the control valve is not up for the job, or final control element is not up for the job, then your whole system performance will be greatly impacted or limited. So this is a pretty important thing down there. And as electricians, we don't dealing with the valve too much. So do you want me to test you a lot on the valves? Probably not, right? So you're only gonna have 4 very basic questions about the control valves. As electricians, we want you to know certain things, but not everything. So this is the final control element, and usually a valve have 3 parts: the body, the actuator, the position controller or signal converter. They usually consider the weak link in the system because if the control valve is not doing good job, the whole automatic control is not gonna be performing as it's expected. To choose a right valve involve a lot of experience and everything else, and we as electrician usually we don't have those we don't have that ability. But don't worry, we're just going to, we're not going to test you on there. It takes a lot of years experience when you're actually working in there to get those type of experience and everything. Okay, I'm going to show you something first. It's a spring and the diaphragm actuator. The valve controls the flow in a pipe by varying the size of passages through which the flow flows. Here's the pipe, here's the valve body, the actuator. The valve body is the house, provide the inlet and outlet. And also a movable restriction is the plug. The restrictor varies the opening for the fluid to flow. This is the plug and everything. Here the stern, which can be controlled. So this is the setting. I think where the inlet part, if this one open, then can flow go through there to go out. The actuator provides the force needed to physically move the restrictor. So they usually have a spring, have a diaphragm, use the air to control that. The air pressure can go in there. We have air to open and air to close. That's the next one we're talking about. It's more related to the safety and everything. Valve actuator, the diaphragm move until create equal but opposite force against the spring. At this position, the motion stop. The plug and the valve stern to which the diaphragm connected in a balanced state. No air pressure. The valve stern is pushed upward by the spring. Standard, usually we're talking about 3 to 15 is standard pressure, right? So 15 is the maximum pressure. If you have a 15 psi pressure, you're gonna, the diaphragm gotta push it down against the spring, so your plug is gonna be closed. The pressure can control the position of so that's the maximum pressure, and this is the plug is at the lowest position. The plug is attached to this stern and it's connect on there. And if you release the pressure, the plug is gonna go up. So usually at the 3, it should be fully open. This type of valve capable of exerting large force. Force depends on the size of the diaphragm and how much air is applied to it. (15 psi). Pressure of a standard pneumatic air signal applied to a diaphragm have a diameter of 10 inch. The actuator provides a force of 1,177.5 pounds. So this is talking about the spring and the diaphragm for this actuator, how they control this thing, move up and down. The control valve by the box definition, section module 7, and on page 6. It's a pneumatic, hydraulic, or electrical powered actuator automatically fully or partially open close to a position dictated by a signal transmitted from the controller. That's the muscle of the automation control. It could be considered as an amplifier to boost the control signal. All those things. There's a few videos we can watch. To give you some basic understanding of the control valves. That's a link. It's not so this is. Can you guys hear?
Yeah.
Okay.
Control valve actuators control fluid in a pipe by varying the orifice size through which the fluid flows. Control valves contain two major components, the valve body and the valve actuator. The valve body provides the fluid connections and a movable restrictor comprised of a valve stem and plug that is in contact with the fluid that varies the flow. The valve actuator is the component that physically moves the restrictor to vary the fluid flow. Three actuator types are used in control valves, and they include spring and diaphragm, solenoid, and motor. As the name suggests, the spring and diaphragm actuator uses a spring and a diaphragm to move the valve stem and plug. A 15 psi pneumatic signal enters the housing at the top of the actuator. As pressure is exerted on the diaphragm, a downward force is applied against the spring, which moves the restrictor. the diaphragm moves until it creates an equal but opposing force against the spring, at which time the motion stops as the plug meets the valve seat. With no air pressure, the restrictor is pushed upward by the spring to act as a normally open control valve. To vary the position of the restrictor and flow through the valve, a current-to-pressure transducer can be used to provide a 3 to 15 psi signal to the diaphragm. At 3 psi, the valve is maintained open, and at 15 psi, the valve is maintained closed. Pressures between the 3 to 15 psi range proportionally change the flow of the valve. For example, a pressure of 9 psi applied to the diaphragm moves the spring and valve stem to 50% of operating range. For on-off control of the valve, a solenoid is used to actuate the valve to a fully closed or fully open position. Applying current to the coil generates a magnetic field that moves the plunger downward against the return spring. With zero current applied to the coil, the spring pulls the plunger upwards to the fully open position for a normally open state control valve. Another method for variable valve positioning uses a motor and is referred to as proportional control mode. Using a gear motor attached to the valve stem, a servo amplifier provides a DC control signal that moves the valve to the desired position. Feedback is achieved with a wiper arm attached to the valve stem that sends a signal back to the servo amplifier where the position is monitored. The servo amplifier drives the motor until the control signal is equal to the feedback signal.
Okay, there's another video.
I'm going to explain to you how the globe, gate, ball, plug, butterfly, diaphragm, check, pinch and safety valves work. I'm also going to tell you about the different types of valve classification, how valves get their names and what valves actually do.
Okay.
So let's start with the basics. How do we name a valve? Almost always, valves get their name from the type of disc used. The disc is the part of the valve that is used to open, close or regulate the flow through the valve. Regulating the flow is referred to as throttling. What we're looking at now is a ball valve because of the ball-like shape of the disc. The butterfly valve is named because of its similar appearance to a butterfly, and a gate valve is named because of its similar appearance to a gate. There are exceptions to the rule though. Globe valves are named after the shape of the valve body itself. Valves are used for stopping and starting flow, varying the amount of flow, controlling the direction of flow, regulating downstream system or process pressure, and finally for relieving system over and under pressure. Valves can be categorized as rotary or linear motion valves. Rotary valves are those which require a quarter of a turn in order to change position from fully open to fully closed, or vice versa. Rotary valves are fast-acting valves. Examples of rotary valves would include the ball, plug, and butterfly valves. Linear motion valves are slower to operate than quarter-turn valves. Linear motion valves raise or lower the disc in order to open, regulate or close the flow through the valve. Examples of linear motion valves include the gate and globe type valves. There are four main types of actuators used to operate the valves. These are mechanical, electrical, hydraulic and pneumatic. A ball valve is a rotary motion valve that uses a ball-shaped disc to stop or start flow. When the valve handle is turned to open the valve, the ball rotates to a point where the hole through the ball is in line with the valve body inlet and outlet. When the valve is shut, the ball is rotated so that the hole is perpendicular to the flow opening of the valve body and the flow is stopped. Ball valves are not suitable for throttling or regulating flow. The pressure drop across ball valves when fully open is very low. Small to medium-sized ball valves are fast-acting quarter-turn valves. Larger ball valves employ a planetary gearbox. The planetary gearbox allows the use of a relatively small hand wheel and operating force to operate a fairly large valve. A butterfly valve is a rotary motion valve that is used to stop, regulate and start flow. Like all quarter-turn valves, the butterfly valve is fast-acting. Larger butterfly valves employ planetary-type gearboxes. Butterfly valves possess many advantages over gate, globe, plug and ball-type valves, especially for larger applications. Savings in weight, space and cost are the most obvious advantages. The pressure drop across the butterfly valve when the valve is fully open is low. Butterfly valves are very well suited for the handling of large flows of liquids or gases at relatively low pressures. A diaphragm valve is a linear motion type valve that is used to start, regulate or stop fluid flow. A flexible diaphragm can be raised or lowered onto the valve seat in order to open or close the valve. A great advantage with the diaphragm type valve is that very few parts are exposed to the flowing medium. The valve is constructed so that only the flexible diaphragm and internal valve flow passages are exposed to the flowing medium. This makes it particularly well suited for the handling of corrosive fluids, fibrous slurries, radioactive fluids, or other fluids that must remain free from contamination. Gate valves are the most common type of valves employed today. Gate valve is a linear motion type valve used to start or stop flow. It is not suitable for regulating flow. The name gate is derived from the appearance of the valve disc. The disc of the gate valve is completely removed from the flow stream when the valve is fully open. This allows flow through the valve with virtually no resistance. This gives the valve a very low pressure drop across the valve. The major advantages with the gate valve are that it is cheap, has a simple design, and there is a very low pressure drop across the valve when it is fully open. The major disadvantages with gate valves are that they are not suitable for throttling applications. They're also prone to excessive vibration when only partially open. Compared to a globe valve, they are more susceptible to seat and disc wear and potential leaking. A globe valve is a linear motion valve used to stop, start and regulate fluid flow. There are four main globe valve designs: straight flow, angle flow, cross flow and Y flow. Compared to a gate valve, a globe valve generally yields much less seat leakage. This is because the disc to seat ring contact is more at right angles, which permits the force of closing to tightly seat the disc. Globe valves are almost always installed with the system pressure on the underside of the valve seat. This makes it easier to open the valve and also removes the pressure on the stem, packing and bonnet when the valve is closed. The largest disadvantage with a globe valve is that there is a relatively large pressure drop across the valve. In addition, large globe valve sizes require considerable power to operate and are especially noisy in high pressure applications. Globe valves are also often heavier than other type of valves with the same flow rating. Pinch valves are inexpensive and are the simplest of any valve design. The pinch control valve consists of a sleeve moulded of rubber or other synthetic material and a pinching mechanism. Pinch valves can be used to start, stop, or regulate flow. However, the effective throttling range is usually between 10% and 95% of the rated flow capacity. There is almost no pressure drop across a pinch valve. Pinch valves are ideally suited for the handling of slurries with large amounts of suspended solids. This is because they have a very large seating area. Because the operating mechanisms of the valve are completely isolated from the flowing medium, these valves are very well suited where corrosion or metal contamination of the flowing medium might be a problem. A plug valve is a rotary motion valve used to start or stop flow. The name is derived from the shape of the disc, which resembles a plug. The design is very similar to a ball valve, although the shape of the disc is different. In the open position, the passage in the plug lines up with the inlet and outlet ports of the valve body. When the plug is turned 90 degrees from the open position, the solid part of the plug blocks the ports and stops flow. When the plug valve is fully open, there is a very low pressure drop across the valve. An important characteristic of the plug valve is that it is easy to adapt for multi-port applications. The use of a multi-port valve, depending upon the number of ports in the plug valve, eliminates the need of as many as 4 conventional shutoff valves. This is a considerable cost and space saving. Plug valves are often used in non-throttling on-off applications, particularly where the valve must be operated frequently. Check valves are designed to prevent the reversal of flow in a piping system. These valves are activated by the flowing material in the pipeline. The pressure of the fluid passing through the system opens the valve, whilst any reversal of flow will close the valve. Closure is accomplished by the weight of the check mechanism, by back pressure, by a spring, or by any combination of these means. The most common type of check valves are the swing, tilting disc, piston, butterfly, and stop valves. The type of check valve used will depend upon the system pressure, temperature, and flow requirements. For example, swing check valves are very well suited for medium velocity, high volume flow applications. There is also a relatively low pressure drop across this type of valve. A needle valve is used to make relatively fine adjustments in the amount of fluid flow. The most distinguishing characteristic of a needle valve is the long, tapered needle-like point on the end of the valve stem. The needle acts as a disc. The longer part of the needle is smaller than the orifice in the valve seat and passes through the orifice before the needle seats. This arrangement permits a very gradual increase or decrease in the size of the opening. Needle valves are frequently used as metering valves. This is because the number of turns of the hand wheel can be directly correlated to the amount of flow. Relief and safety valves prevent equipment damage by relieving accidental system overpressurization. A relief valve gradually opens as the inlet pressure increases above the set point. The valve only opens enough to relieve the overpressure condition, whereas a safety valve rapidly pops fully open as soon as the pressure setting is reached, and it will stay fully open until the pressure drops below a reset pressure. Solenoid valves are electromechanically operated valves. They are very well suited to opening and closing operations. They can be used to start or stop flow, but are not well suited for regulating flow. This type of valve is fast acting. An electromagnet is used to operate the valve when current is supplied to the windings. A spring is used to return the valve to its fail-safe position when the electrical current is no longer present.
that's another thing what we said. I cannot only teach you what's on the exam, right? I have to give you certain amount of information, right? And in the book here, they talking some very basic thing, and they talking about the valves, dynamic gain losing or static gain. That's not too useful. So that's why we found those videos give you some basic idea, because especially for us as electricians, any of you guys been working with valves? No, right? But in the industrial control, those air pressure controlled valve is very common. Milan, you working with valves a lot? Oh, yeah. That's if you're working on fire alarm, you're only doing is those flow and think of flow and the temper. Oh, Milan, you're working in industrial with lots of valves in control? Oh, okay. Yeah. Yeah, I will tell you what you need to know. So I have one more video to show you and give you some basic idea, because not everyone, like especially electricians, we don't working on valves.
In today's video, I'll be showing you how the most common types of valves work. Let's start with the most common valve, ball valve. As the name states, there is a metal ball with a hollow bore that is approximately the size of the inner diameter, or ID, of the pipe. This is an important feature because the valve is open and it doesn't obstruct the flow. This feature also allows the valve and the following pipe to be inspected or drain snake. The ball design also allows for maximum contact area, which results in much tighter seal. They are durable, performing well after many cycles without leaks. Because the valve seals are not directly exposed to inline elements and debris. They are also very reliable. They can survive in dirty and harsh environments and can operate even after long periods without regular cycling. I have personally seen ball valves operate even after 40 years in an industrial setup. They're best suited for shut-off applications thanks to their quarter turn or 90-degree open/close design. The quarter turn action also makes ball valves very difficult to fine-tune and control output, so they are not recommended for fine flow control. Another shut-off valve is a gate valve. It works by raising and lowering a gate. Similar to ball valve, they operate without obstruction and leave the pipeline open for inspection. Lowering and raising the gate puts a lot of wear and tear on the spiral stem, and they are not recommended for flow control. When the gate valve is open and operational, debris can settle in the seal, or seal erosion from the flow occurs naturally. Furthermore, the sealing surface around the edges of the gate provide a very thin contact area, making gate valves very prone to leaks. Gate valves, however, are used for temporary work on the pipelines due to their lightweight and their compact design when compared to ball valves. Their seals are regularly maintained to prevent leaking. Next, we have the most common household valve, which is the globe valve. The diverting arms provide the greatest resistance to flow, allowing for very easy and precise control. Globe valves are designed to be directional. If the flow is reversed, then the constant pressure damages the seal around the stem, which can cause leaks or total failure of the valve. They are also used at end termination shutoff valves. When installed correctly, for example, at a tap or faucet where flow control is required, as well as a perfect shutoff with an excellent seal. Globe valves should never be used as shutoff valves in between a piping system. Now there is a variation when it comes to globe valves, and that is solenoid or mag valves, which is magnetic or coil based. Important note is that the diagram shows a normally closed valve. When current passes through the coil, a magnetic field is generated, which pulls the metal stem, compressing the spring. As long as the voltage is present, the valve will remain open. And as soon as the power is cut off, the spring pushes on the stem to seal the valve. Lastly, we have the other valves that are not as common, but still very essential to any system. Let's look at another quarter turn valve, the butterfly valve. In the little diagram, you can see that a metal disc pivots to restrict flow, hence the name butterfly. They are perfect for controlling the flow, and they are still regarded as quarter turn because of the disc action, even though some of them come with a small gearbox for even finer flow control. Butterfly valves are not used for shutoff applications as they are very prone to leaks. Next, we have check valves. Check valves never get any attention because they are basically set it and forget it type of valve. They only permit flow in one direction, meaning they are directional. In the diagram, the spring compresses the disc, is released from the seal when there is flow. When the flow changes direction, the disc is pressed against the seal. They are best suited for maintaining a separation, for example, keeping hot and cold water from mixing together under the sink, or as a safety net to prevent reverse flow in a fish tank. There's another variation to check valves with a small change. If the check valve seal is extended, then a check valve can be made into a pressure relief valve, where the valve opens and expels excess pressure buildup. The diagram shows preset relief valve, where the spring is designed and calibrated to reduce pressure buildup. The spring compresses till the seal is pushed past the sealing chamber, and then pressure is released until the spring overpowers the pressure and reseals the valve. These valves have saved lives by keeping operating pressure within safe range. And the best part about relief valve is that the failure occurs at the seal. And when that happens, the relief valve just prevents any pressure from building within the system. So a quick change and you're back up in operation. In conclusion, we can see all the different types of valves working. They can be easily identified based on their action, or their seals, or their flow control. The important thing is to keep them operational as a safety net. I hope you liked this video. Thank you for watching.
So that's just some basic idea about application and the valves involved in the control. Some of them now in the automatic control, but the video usually they explain a lot. General category of control valve, it can be pneumatic, electrical, or hydraulic. Control of actuator, usually they translate a special output signal from the control into the position. That's most common is in the automatic control, you have either current signal or voltage signal to activate them to make the pneumatic is I saw a lot in control industry because the air pressure to operate them is much easier. Linear, rotary, you already know them, and by watching the video. Single pole, double pole is depends on sometime each have its own advantage and disadvantages. This double pole will be much more easy to balance, but it's hard to close and open at the same time because you have two opening down there. So they are tight closure is poorer than single set of valves. Valve action and the fail-safe operation. So some of the valve is air to open, some of them is air to close. For the fail-safe operation, it's whether your control signal is a fail or if your air supply is not there, you have to be able either to close the valve or open the valve, depends on your applications. So for here, they're talking about air to open. If overheating, we damage the material in the tank, air to open valve shall be used. I think, Sebastian, the question you ask is in module 3. So if you're preventing the overheating, it's going to use air to open valve because if you keep supplying that steam and when the control signals fail or air signals fail, you use air to close one because you don't have the air, you cannot close it. The heating is always going to go to the tank. That's where it's going to cause damage down there. The air to close one, that will become a normally open valves. One is normally closed. So if the material in the tank will be damaged, if the temperature will drop below a certain level, air to close valve should be used. So because you want to keep the temperature down there, it's not going to be subject to overheating problem. If your air is failing or your control signal is failing, and then your valves will always be open, so you always have the heating supply to the tank. That's where how you choose air to open and the air to close depends on the application down here. Also, this normal close, normal open. I think this is a very important thing. It's a safety thing. It's very important, so you better know this. This probably gonna be, you're gonna encounter some kind of those questions. Yes? No? Yeah, you have to know this. To choose the air to open or air to close. I have another thing to show you pretty quick. It's, so it's another program to explain this air to open, air to close. This is the air to close. This is the air to open. And it's also depends on the valve setting. This air to close is normal open. This air to open is normal close. Term air to open, air to indicating whether the plug will be open or closed. The power at the valve sets when the valve is actuated by the air. Style select depends on the fail-safe position required if a control signal which activate valve fail to occur. So it's air to open, being heated by a steam jacket that surrounded, and temperature is regulated by the amount of steam flows through the control valves. If overheat, we damage the material in the tank. The air open valve shall be used. Suppose air to close valve used. So if we use the air to close one, the pressure was lost due to accident breaking in the airline. The valve will open fully, allow maximum steam to flow into jacket, cause the ingredient to overheat. So that's an opening down there. The airline got broken, got all the steam into to heat the tank. So that's not going to be a safe air to open. In this situation, air open valve should be used because if we close, not allow steam to in there if supply was lost. So without the air, it closes. There's not going to be any steam in there. Air to close. But this type is going to be different requirement. The temperature regulated by that, and if the material in the tank will be damaged if temperature drop below a certain level, air to close valve should be used. So if there's an opening down there, you use air to close. So there's going to be not any steam in there. You're going to damage that. So if you have a leaking air pipe, the valve's fully open, so the steam still can in there to heat the ingredient up. Okay. When air is supplied, which valve is closed? Hayden? Guys want to give an answer?
A.
A? You sure?
Air to open is normally closed valve.
But here they ask when the air is supplied, which valve is closed?
Oh,
I guess he's sleeping in my class.
no. Whoops.
Okay, you lost your bonus mark now. Which valve opens when the air supply to the actuator is lost? B is the right answer, right? Air to close. So if you lost the air, this valve will be automatically open. To avoid damage to product from overheating, what type of valve should be used in the event where the air supply is accidentally lost?
A.
Now you get it right. Okay. So, like I said, you're probably gonna encounter question about this air open, air close. Make sure you know this. Okay, next one. This is just this is a picture from your book. You can see that on page 7-15. That's the same illustration down there. Selection consideration. For us as an electrician, as long as you know those safety things, that should be good enough. Okay, so that's all for this one. Here's a few things I'd like you guys to know. They talking about all those valves, right? So the control valve can control can it control liquid? Can it control gas? Can it control steam? Yes, no? Yeah, so doesn't matter if it's a liquid, if it's a gas, or if it's a vapor. Sometimes they will give you this is water or oil or maybe hydrogen, or maybe steam. So, or slashes, yeah, same thing as all the flues. Another one I think we mentioned before is for the automatic controls. Either you call the control process or control systems. They have both open loop and the closed loop, right? Don't just thinking about all the automatic control have to be closed loop. So you could have open loop automatic control system. And one more thing is a control process or the control process for a product. You might try to make something or build something. That's most the industrial process, the purpose, right? And any of the change, you could be temperature, pressure, it could be the liquid level, it could be the fluid flow rate, or so lots of things. If any of those change can affect the final product. So that's why when we talking about automated controls, when we talking about the system, and we have to That's why we have to do the measurement. We have to do the controlling of those things. So those are gonna be important things for this module 7. And if you get version F exam, you have to know everything about all different type of valves and how they works. Even for the books, they're talking about something. I think they're talking about this this value called the valves rangeability, those type of thing, and also this coefficiency, static gain, dynamic gain. Oh, one more thing. You guys know what a gain is, right? Any control system, the gain is equal to the output. So this is they're talking about the static gain, but the whole control system gain is the output compared to the input, right? So if your output change how much compared to the input change how much, that will give you the gain or static gain for the system. Then if you're not doing the version F exam, I think how many people? Maybe two guys in this class who were doing version F exam. I will pick those questions for you. Other than that, don't worry about those things. Yeah, Ethan, I think you are the guy going to do version F exam. Okay, so it's 10:30. We kind of like matching our goal here. We finished everything in Thursday morning. This afternoon, basically, if you have a question, I will try to answer your question. If you ask me some question I cannot answer, probably it's not important for you to know also. So if you want me to go over anything you think is important to know, I will try to go over. Other than that, I think you guys, if you stay in my class and you paid attention to what's important in this course, you should get a pretty decent or high mark for this course. Let's take a lunch break, and I will see you guys 11:30. Yeah, if you want, we can do practice calculations. Okay, back here at 11:30.